In this first module of your ICMP1 studies, we're going to cover a ton of basics. We'll begin with a look at a couple of super popular network reference models that you've got to know if you want to talk the talk of a network professional. We'll talk in theory about some of the different pieces and parts that make up a network, different ways of interconnecting those components, how things get cabled together, and a look at basic troubleshooting skills for those times, and there's going to be plenty of those times when things just don't go as expected. And finally, the two longest lessons in this module get into IP addressing, both IP version 4 and IP version 6. And I cannot stress enough how critical it is that you thoroughly understand those topics. Now, let's get going by exploring what these network reference models are all about. One of the most basic concepts we've got to understand as a network professional is the concept of the OSI model. OSI, that stands for Open Systems Interconnect Model. One of the most important reasons it's critical to understand this concept is throughout your career, you're going to be reading or you're going to be hearing someone talk about a piece of software or a piece of hardware. And they might say, or you might read that a particular piece of hardware lives at layer 3 of the OSI model, or a piece of software lives at layer 6 of the OSI model. The OSI model contains 7 different layers that we're going to be discussing. And you might hear, for example, somebody say that switches live at layer 2 of that model. You might hear somebody say, or you might read that routers live at layer 3. And as we talk about the OSI model, it can become a bit of acronym soup. Here's what I mean by that. Technically, this OSI model is the ISO OSI model. ISO, that's a standards body, the International Standards Organization, and they defined this Open Systems Interconnect, or this OSI model. And we've said that this model has 7 different layers. And some people get a bit confused about how the layers are numbered. Here's the way I want you to think of it. Layer 1 of the physical layer, that lives at the bottom of the model. Think of that layer 1 being like floor number 1 on a building. As you go into a building and you're looking at the building directory, the floors start at the bottom and go up. Same thing with the OSI model. The layer numbers, they start at the bottom and they go up. Layer 1 is the physical layer, and the physical layer is concerned about how to get data on the wire. We're talking about the individual bits, the ones and zeros. How do we electrically represent them, or how do we optically represent them if we're using fiber optics? Moving up to layer 2, we have the data link layer. To give you one example of something that resides at the data link layer, think of an Ethernet switch. An Ethernet switch in its basic form is a layer 2 device because it can make forwarding decisions based on an address that's burned in to the network interface card in a PC, as an example. That burned in address is called a MAC address, MAC, Media Access Control Address. It's a 48-bit address, and this layer 2 device can make forwarding decisions based on that 48-bit address. Moving up to layer 3, instead of making forwarding decisions based on physical addresses, here at the network layer, at layer 3, we might have something like a router, and that router could make a forwarding decision based on a logical address, such as an IP address. Most of our discussion is going to be revolving around IP, both IP versions 4 and 6. But remember, back in the day when the OSI model was originally created, it was meant to be a very generic model where it would apply not just to IP traffic, but other types of traffic. For example, IPX, Apple Talk. But again, our main focus is going to be on IP, and we can have IP addresses, logical addresses at layer 3, and we can have a piece of hardware, a router at layer 3, that can make a forwarding decision based on those logical addresses. Layer 4 is the transport layer, and again, to give you just a couple of examples of things that live at the transport layer, we've got a couple of really popular protocols, TCP and UDP, and we're going to be contrasting those coming up. For now, just understand that TCP is a reliable protocol. In other words, if I send you a layer 4 segment, that's a piece of data at layer 4, and I'm using TCP, I'm going to expect you to acknowledge that. I want you to tell me that, yes, I got the data, I'm ready for you to send me more data. Contrast that with UDP. With UDP, I'll send you data, and I hope you get it, but I'm not going to expect you to acknowledge the receipt of that data. Just a couple of examples of protocols we see at the transport layer. Now, the upper 3 layers, layer 5 of the session layer, layer 6, the presentation layer, and layer 7, the application layer, honestly, things start to blur a little bit when we get into these upper layers. You might be looking at a network and all of the applications and appliances making up that network, and you might have difficulty finding something that lives at layer 5, and that's okay. Please keep in mind, you do not have to neatly populate each one of these layers. Not everything fits neatly into a specific layer. You might have a protocol or a piece of hardware that lives at more than one layer. That's okay. Remember, this is just a reference model. But in general, layer 5, the session layer, is responsible for setting up, maintaining, and then tearing down sessions. The first such protocol that comes to mind is SIP, the Session Initiation Protocol. If you deal with voice over IP networks, where you're setting up phone calls using an IP network, many IP phones will use the Session Initiation Protocol to set up, maintain, and then tear down a phone call. Up at the presentation layer, layer 6, we're concerned about how data is represented on the network. For example, we might format a block of text using ASCII, or an old way of doing that was using EBCDIC. Something else that we might do at the presentation layer, though, is encryption. We might want to take our data before we send it out over an untrusted network like the internet, and we might want to scramble it up. That way, if a malicious user intercepts that data on its way to the destination, they're not going to be able to read that data because it's all scrambled up. It's encrypted, but the intended recipient, they're going to be able to decrypt that data. And up at the top, we have layer 7, the application layer, and this is one of the most challenging layers to understand because I think the name is confusing. When we see the name application, we might be tempted to think of something like Microsoft Word, a desktop application, but that's not what this is referring to. We're not talking about an end-user application that they're going to run on their desktop computer. No, something that lives at the application layer is some sort of a network service that allows other desktop applications to take advantage of that service. For example, maybe you have Microsoft Active Directory in your environment. That can act as a single repository of usernames and passwords, and you can have a variety of desktop applications query that Active Directory database. You might be querying that database when you're logging onto the network, when you're trying to open up a file on a file server, when you're checking your email. That service, that Microsoft Active Directory service, living at the application layer, is providing that network service to end user applications. And one of the goals I have for you is to memorize these 7 layers of the OSI model. Let me share with you a couple of really popular memory aids that can help you remember in order these 7 different layers. We could start at layer 7 and go down. And if you want to remember that way, starting at the top and going down, you could remember the acrostic, all people seem to need data processing, where the A in all reminds us of the A in application. The P in people reminds us of the P in presentation, and so on. All people seem to need data processing. If we want to memorize these layers from the bottom up, beginning at layer 1 and then going through layer 7, we could remember the acrostic, please do not throw sausage pizza away, where the P in please reminds us of the P in physical, and the D in do reminds us of the D in data link. Please do not throw sausage pizza away. And the best metaphor I've ever heard for the 7-layer OSI model is the metaphor of a bookshelf. Here's a picture of a bookshelf that I have in my home, and it's somewhat organized. In the lower left-hand side, we've got some books that I've written for Cisco Press. Just above that, I've got my Star Wars books. Things are fairly organized. However, you might notice in a couple of these shelves, I don't have any books. And that's a lot like the OSI model. We do have like-minded applications and devices grouped together in layers or shelves like we have here, but there's no requirement for us to populate every single shelf. We might not have something, like I mentioned earlier, acting as a layer 5 session protocol, and this is one of the most challenging concepts for some people to get. I've seen some people that are just not satisfied unless they can clearly map every single thing in their network to a specific layer. And I've had people argue with me about what's going on at one layer versus what's going on at another layer. They might say, I thought security happened at the presentation layer, and now we're saying it happens at some other layer. Well, a couple of things to keep in mind. Remember, the OSI model is very generic. It was designed for more than just IP. IP might have certain features that live at certain layers, but that does not necessarily apply to all other protocols. And also, I want you to remember the best piece of advice I ever received regarding the OSI model, and that is, remember, the OSI model is a reference model. It's not a reverence model. It's not to be revered as the master template into which we have to plug every single application and protocol very neatly with very clearly defined functions. Now, this is supposed to help us better communicate with one another about different types of hardware, software, protocols, and it's fairly common when you're talking to another network professional to refer to a specific layer of the OSI model. But remember, the OSI model was designed to be very comprehensive. It wasn't just focused on IP-based protocols, but typically today's networks are running on IP version 4 and or IP version 6. And there's another reference model that focuses specifically on the TCP/IP stack, which is also known as the DoD or Department of Defense model. So we can use those terms interchangeably. TCP/IP model, or some people say TCP/IP stack, or the DoD model. Let's talk about that IP-centric model in the next video.